I measured MARC records. MARC is a library format. It stands for Machine Readable Cataloging. It has a long history, not as long as the Greek language, but in computer science it's quite long. It was started the designing about 1958, and it was invented finally at the first half of the 60s. And well, it was the age of punch cards, so the information had to compress, and lots of different things is totally different than what it is right now if we are talking about modern formats. So one important thing is that because of this historical reason, and because of the reason we don't clearly know what MARC records describe, it's the work, manifestation, expression, whatever. We librarians love to hate or criticize MARC, and there's a famous slogan. It's a title of the article, "MARC must die." This guy who wrote this article almost 20 years ago retired last year, but MARC still here. And yeah, one sentence from this famous paper is, "There are only two kinds of people who believe themselves able to read a MARC record without referring to a stack of manuals, a handful of our top catalogers, and those on serious drugs." So this kind of summaries the problems with MARC. So this is a pretty printed example. MARC itself is a binary format, but that's a conventional way how to present it in presentations like this one. Is it rocket science? Kind of. This is rocket science. So this is very similar. This is the Apollo 11 moon landing source code. The philosophy is kind of similar. So they condense the information, and it's not human readable at all. And if we go back, that you cannot see labels like title or author or whatever. These are numbers and dollar signs and codes which represent this information. So that's why we need manuals. So there are different kinds of fields. This is one typical field. So there's one long string, and each position has a different meaning. Sometimes the meaning, the position, depends on some other fields. So, for example, this is 0008, whatever. It contains this part, which is true for every record, and these parts depend on the type of the material. But there's no field for type. It's a combination of many other fields. That's the structure of a normal field. It's called data fields. It might be repeatable or not repeatable. It have two operators called indicators, which modify somehow the meanings. And there might be one or more so-called subfields, which has a code, a value. It also can be repeatable or not repeatable. The value can be a free text, came from a dictionary, or a mixture of different other things. One important thing is that MARC has lots of history, so there's lots of changes and lots of adaptations. So the standard changed over the time. There's one problem that there's no versioning. So you can say that, okay, this MARC was created in the spirit of that kind of versions. The other problem is that there are localized versions. So almost every nation think that okay, Library of Congress created nice things, but we have some national customs how we describe books, and we should create our own MARC format. And they created the standards. Some are documented, some are not documented or not publicly available documented, and also they miss about the versioning. So what I have done is went through the core MARC. Right now it's called MARC 21. It was a major revision 20 years ago, and created a Java data model. And also I checked the available national versions, not every versions, but those who had records I can work with. And in order, it takes some time, and in order others could access this structure, it is exportable to a JSON format. We are working on standardizing this machine-readable standard format. We call it Abram. And yeah, I would like to mention two names. You might see recently this lady, Margaret Hamilton. She was the main brain behind this Apollo code I showed. And by the way, she coined the term software engineer. So all of us who believe that we are software engineer, we should credit her. And the other is Henriette Abram. She was also a software developer, mathematician. She invented MARC, and you can see the discs or tapes and the MARC manuals in her hand. So that was about MARC, and right now about validation. So I follow a kind of workflow in quality assessment. So my workflow is that first I have to get the data, then measure each record, then do some aggregation of these measurements using some statistical or machine learning methods, then create a report, and I have to check the report with the metadata experts and apply a feedback loop that change whatever they tell me that should change, or they can accept and modify the original record, and then I could re-ingest and rerun the same process. So with MARC, I do two kind of measurements. These are the data I ingested for these resources. Different catalogs. There are union catalogs, national libraries, university libraries, public libraries. Most of them are freely available and available under an open license. Some of them are not, but yeah, I shared a list somewhere. So first, this is a measurement. This is a Java code, but I created some command line interface. It's not very important. The output is a CSV file. And then I did two kind of aggregations. It's a good thing that I showed here that there are more than 3,000 data elements in MARC. So I guess that there are lots of dates. I don't know by heart the MARC manual, unfortunately. I'm not one of those guys. But it implies that there are lots of rules. And this is a good thing because on the other hand, for example, if we compare with Dublin Core has only 15 fields and there's no rule at all. So it's very hard to validate Dublin Core records. But MARC has lots of rules, so we can check different things. So these are the numbers. The interesting thing that I separated two kinds of issues. One is every issue, so it's, and the other is filtered. I mentioned previously that there are different versions, and some versions are not, or not. Some MARC versions are not documented, and if a field is not documented, I cannot validate it properly. I can tell that, okay, I cannot decide whether it is good or bad. So this filters, I removed those uncertainties. And yeah, the interesting thing that every of these catalogs has different issues. One catalog contains doesn't contains record without errors, but one of them, this is German National Bibliography, is almost perfect. So it's only 2,000 of the records has some kind of errors which are not about the undefinitions. And here is the list of errors I detected. The bold ones are the most frequent issues. Two of them is because of the undefinition of the fields, and one of them is the invalidity of the code. So these values are not fit with the expectations. But the interesting thing, there's a list in the paper. Almost every catalog has lots of records in different positions. So these three is only the issue types which appears in every catalog. Yeah, the number of the other important question was the completeness. So how complete the record, what are amiss from the records, and here what you can see that in the total column is the number of subfields, which is one of the most frequent data element of MARC. And you can see that there are lots of subfields. For example, in Stanford University, actually there are much more subfields which could be. So they have lots of undefined subfields. I checked them. There's a historical reason for that. So MARC is not just it's just not only for owning, describing the book we have, but it's for exchanging information. And if you get a record from another library who followed a different version and you don't clear the information, you get this kind of garbage or undefined information into your catalog. So that's why they have so many fields. And the second column is that the number of fields which appears at least 1% of the records. And the last column is the number of fields which appears at least 10% of the records. So we can see that these are much less fields. So lots of the fields which are listed here appears only a fraction of the records, which is a good thing because it means that they specify the particular information, so they are not general thing. This is another way of completeness. So these are the most these are the categories of these fields of MARC. And what is in the box are the descriptive information. So the title, when the book was published, who published the book, and so forth. And the rest are some kind of classification, where is the book stored, and authority records. And you can see that this core thing is almost everywhere fully available, while the rest are very differently fulfilled. One of the, I don't remember what I mentioned, but right now I will. 20 years ago, there was a document called FRBR, which provide a new data model for the libraries. And FRBR also defined 12 functions, which is important for the users, like searching, identifying the record, selecting, and so forth. And they provided the map between these functions and the MARC data element. This is also covered in the model. And what you can see that because of this huge number of fields, this support of functions are very low. So it's typically 2, 3, 4% of the fields which can be support given function is available. But again, because there are 3,000 data elements and about 100 element is available in a particular record on average. So only for functions, this kind of completeness matrix is discriminative. Okay, and another kind of completeness model is Thompson Trail suggested a model. They had a problem that they are American catalogers, and their libraries buy ebooks. And with each ebooks, they get the metadata record. And different vendors provided the same books, and sometimes 3, 4, 5 metadata record they get for each book. So they wanted to check the best. So they created the model. They think about the most important fields, whether they are available in this MARC records or not, and give a score. And this graph shows a k-mean clustering of one particular libraries. And you can see that on the right side there's a big blue group, which means that from 0 to 1, it gets 5 as a score for this completeness matrix, and this group contains 8 million records, and this is quite good. So this represents a kind of acceptable average. It's not very high, but not very low as well. And the green represent a lower cluster. It contains 4 million record, but it's about 0.1, so it's very low quality. I should mention that this model is very specific to ebooks, and particularly in American cataloging customs, because they expected Library of Congress subject headings and different things which are not used in Germany or Netherlands. And a part of this project is a user interface, so it's not just the CVS file, but there's a web interface where you can check the catalogers can check the issues. Each issue has a information link, so this I represents a link to the MARC standard. So you can check why this particular value is a problem. And also, if you click on the numbers, you can get the particular records which belongs to this problem. There's a completeness interface, and there's a search interface where the interesting thing is that it's not very fancy, so it's not as good as a normal discovery interface, but there's one particular important thing, is that the facets are customizable, and every field can be facetable. So by default, it's indexed in a way that you can find facets, and it's important because it's a very handy tool to find particular issues. So, for example, this Van den Hoek and Rupert is a publishing house in Göttingen. It's very old publishing house, and this is from one catalog, and you can see that there are lots of name forms. Most of the forms are valid. So the publishing house were established in the 18th century, so it has lots of history. So und, et, and so forth are valid, but sometimes it's Van den Hoed and Van den Hoed instead of K or CK. And yeah, there are two future development is that applying named entity recognition, but within these 2 days I'm a little bit skeptic. I became skeptic. This is called responsibility statement. This describes who created the particular book and what were the contribution, and the MARC catalog can contain authority entries. And in this particular record, 4 of the contribution has authority entry, but 1 doesn't have. So with named entity recognition, we probably find this one which doesn't have this authority entries. And there's another thing is applying visualization to find different issues with the catalog. So in the x-axis is the publication of the book, and on the y-axis is the time of the cataloging. And if you see here that this box contains that these books were not published when they were cataloged. So for some times it is reasonable. So publishers reports the national libraries that we will publish later these books, and they created a preliminary record for them. But if it's more than 10 years, it's not possible, I guess. So that was it. And the source code is available both for the validation and the user interface. Here's a Abram specification which contains the JSON format of the MARC standards, and in Göttingen, a colleague, Jakob, was working on Pika and other metadata standards to turn into this format. And if you want, you can use in Python or whatever language you prefer. Thank you very much.
Thank you very much, and I loved one of the comments on Twitter. Somebody was very passionate about bringing DATeCH and ELAG, which is happening that's the European Library Automation Group, which is its conference is happening at the same time, bringing those together in one talk. So thank you, Peter. Has anybody got any questions for Peter?
Hello. Do you have any plans to add the functionality to explore those data in more modern formats as the RDA specification or any other one which is real, not as old as MARC?
You mean the MARC record or the validation report?
The MARC record to transform the MARC record into more modern formats as the FRBR, RDA specifications.
Personally, I don't work in this area, but yeah, there are lots of different projects and efforts, and standardization is going on in this field. So if you are interested, there's the best place maybe. There's a big American project called LD4L, something like that. It's linked data for libraries, and it's the Library of Congress, Harvard, Stanford, Cornell, Columbia. They working on different segments of different document types, which currently recorded in MARC format, to transform into some kind of FRBR based format. So there are multiple standards. Right now, it seems that a format called BIFrame is the winner, but it's too early to say that this is a clear winner. But at least lots of libraries working with BIFrame.
If you show this to libraries, do they say, uh-oh, let's fix this, or what happens now?
With libraries, it's just this communication is just kind of started. So I'm connection with 3-4 libraries. As far as I know, some libraries improved something. So I worked with the Finnish National Library and Ghent University Library. They said that it's useful for them. Yeah, others I don't know. In my other in my research topic, my other big format I'm working with is Europeana data model, and within Europeana I'm participating in a data quality committee, which tries to bring together different aspects into the same table. So metadata experts, software developers, DH persons, and of course Europeana's ingestion team, and in weekly or biweekly frequency we discuss these kind of things.
Oh.
Maybe I can add, speaking for a library, I know similar exercises on, oh, sorry, thank you. I know similar exercises on library data, and so far we have done it for our library, and we have some of these instant views are very similar, and we try to improve it in small steps and surrounding of MARC 21 or MARC XML. That's one area of interest. I was wondering that you haven't used the culture graph approach as a common approach to gather data together and publish them in different formats and make them workable to one of the most strongly or seriously problems one has to solve is the matching of these different data, because many of them are more or less duplicates, and this is, I would like to know how you have made that. This is one of the issues libraries have to cover, and this is really difficult. And within culture graph you have the data in a different format with many tools to aggregate and compile this data. This is a challenge. And okay, the third aspect is the move to another data schema, and you have mentioned BibFrame and the different activities to transform the data into a linked data style, and I think there are many libraries who have done that. Till now, there is no existing platform working on the level of and the philosophy of enriched data, entity-oriented on the linked data approach. But it's an ongoing discussion, and I think many libraries are here involved. So it's a step-by-step approach.
Yeah, in this research I did not enter this field because there are existing players like Culture Graph, OCLC. They are working on clustering the data, and yeah, it's a very hard topic. So there are some papers, not too many, and to tell the truth, I haven't seen any good solution yet. So everybody is trying, and so it's a try and error kind of process.
But MARC, it was established in the 60s, and I think MARC 21, with the current status, is in the 90s or the end of 80s. So there is a lot of history behind this data, and that's the point.
Yeah, true. Yeah. One more sentence that if you are interested in this area, I'm very happy to collaborate, either in MARC, either other kind of other metadata formats.